said what to do? Homework. You had a graph that you did with your data, and then you were supposed to do the questions. Before we do this, because this is going to jump us into what we're doing today, let's get out that assignment from last night so that we can go over it. Get it out so we can go over it. I want to make sure that we feel good about heat capacity. So get it out and let's talk about it. I'm not going to walk around and I'm not going to check it because I don't feel like putting a bunch of zeros in the grade book for those of you who are like, I didn't do it. I'm not going to do it. You're welcome.
What if you didn't get a zero?
So what we're going to do is we're going to have just a little conversation, the same conversation that we had with my first hour class. You are going to not talk while I go ahead and tell you. Get that out of your ear. Look at my face. Thank you. What I need you to do is I need you to listen to me because it does me no good to go ahead and work hard to put together these lesson plans if you then don't follow through with them. Here's how education works. I teach you something, then you go home and you process it by practicing. If you go home and you do nothing, you are not doing your part of the bargain, okay? That's what's happening. And then I hear you say, I didn't do well on my exam, I just can't do science. That's baloney. It's not that you can't do science, you're not giving yourself a chance to process the information so that you can retain it for the exam. So if you are not doing the outside work, then that's your issue, and you can change that. Control what you can control in life. I can only do 50%. You have to come to me with the other 50%. Do you understand what I'm saying? There are so many people out there that would love a free education like you are getting right now. They come to this country so that their children can come here and get that free education. And some of you are pissing it away. I am concerned that you are not doing what you need to do to be successful. Okay, that being said, I love you all dearly. And let's go ahead and talk about what we have. So I'm going to go ahead and pull this up on my end. You get yours out. If you didn't get it done, whatever. Just do me a favor and please get it out now, my loves, so that we can go over this thing and we can look at what it is. All right. This is, I think it's like, what is this? Heat capacity or something like that? What was this called?
It was called
Heating versus cooling?
Yeah.
Got it. Thank you very much. I greatly appreciate it. Let's do this. All right. So then you were supposed to graph something. I'm going to pull up my graphs. Hopefully you got through the graphing, but if you didn't, this is what the graphing looks like. So this is about what you should have had. On my graph, we've got sand in red and we've got water in blue. Does your graph kind of look sort of like mine?
Kind of.
Yeah.
What's up, bud? We're going to have a break in the action, and then you can go, but not now. So if anybody has to go to the restroom, Cole gets to go first, okay? So we've got temperature over here, we've got time down there. What do we notice here? Which material, sand or water, changed its temperature at a faster rate? Turn with your pair share partner and share that out. Ready, set, go.
Sand.
Oh, that was easy. Sand, absolutely. So if we look at what it is we're doing here, before we do that, notice water, it went up, it definitely changed in temperature, definitely not as much as sand, and it held on to its temperature much better than sand did. Sand had a very sharp, steep slope here. When we shut that light off, don't forget, 10 minutes was the mark where we shut that light off right through here. As soon as we shut that light off and moved it away, we saw that sand did a very fast tumble. Desert environment, very similar. Hot, hot, hot during the day when the sun is on it, but then at night, deserts get really, really cold. And this is because of this sort of factor that we're seeing right here. So let's go ahead and look at the questions based on this. All right, the first one should be easy peasy. It says, which material changed the most? And you all said, sand. Sand changed the most. Based on the results of this lab, would California or Iowa have a more constant, meaning stay about the same temperature throughout the year? Turn with your pair share partner and talk about that. Iowa's right here in the middle of the country, surrounded by land, right? It could represent sand, right, in our lab. This is right on the coast, right? It's right next to the ocean. And in our lab, what would have represented the ocean? Water. There you go. So with your pair share partners, talk this out. Ready, set, go. You've got 10 seconds.
California would have said.
Yeah.
3, 2, 1. What do we think? Billy, this question's for you. Which state, California or Iowa, would have more of a constant temperature throughout the year? California. And let's just see if we have data to back that up. I'm going to go all the way back to this. Remember when we looked at our temperatures of the 3 different cities? Which one on this graph represents San Francisco, California? What color?
The green.
The green. What do we notice about its temperature throughout the year?
It stays.
Stays pretty steady. I think that there was somebody in here, Sam, he's like, Mrs. McGray, maybe it has something with being near a large body of water. Sam, is that right? Darn right it's right. Look at Iowa, which is the blue, gets really hot in the summer, and then all of a sudden when it gets cooler, it kind of, drops down. Very much like the graph that we did in our lab. Cheyenne, Wyoming, same thing. Those 2 states are what's called landlocked. They're surrounded by land. They don't have the benefit of a large body of water to help regulate their temperature. You see what I'm saying? All right, let's go ahead then and answer some of these questions. And if you have answered it, awesome. Let's go ahead and see if you meet us. So now explain your reasoning using evidence from the lab. I know this, meaning California will stay more regulated, because in the lab, the water represents California and the sand represents Iowa. During the lab, which one stayed at a more constant temperature? Water, so you should fill that in. During the lab, water, I'm just going to circle it right here. Water stayed at a more constant temperature than sand, just like California, thanks, this is you participating, would stay at a more constant temperature than Iowa. Good job, y'all. All right, let's go ahead and go and figure out why that is. It has something to do with this idea of heat capacity. When light energy from the sun is absorbed by the Earth's surface, that means the energy goes in and stays in. It warms our Earth. For humans to survive, Earth must hold on to this heat, otherwise we'd be little popsicles. The amount of thermal energy, meaning heat energy, needed to increase the temperature of a material by just 1 degree Celsius is called heat capacity. It's the capacity of that material to hold on to heat, okay? Another way to think about heat capacity is that it controls how well a substance holds on to heat. Describe heat capacity in your own words. With your pair share partners, I'm going to give you about 10 seconds to see how could we rewrite that so we understand what heat capacity is. Turn and talk. You've got 10 seconds. Ready, set, go.
Heat capacity is the ability to hold on to heat.
You're going to have to talk out loud to your partner and try to figure it out.
Show us how things heat up.
That's what I'm reading. It's the ability to, say you heat up 2 cups of coffee. One would stay warmer than the other. That one has better heat capacity.
And we are done. What do we think? What could be a way that we describe heat capacity in a way that we understand it in our own words? Heat capacity is well, we're going to run out of time. We're not going to be able to do anything we need to in class today, and then you're going to have homework tonight. God, that's sad for y'all.
There's a hand.
Thank you.
Yeah.
Go ahead, Cullen.
How much heat is needed to warm up a certain material by 1 degree?
Okay. You could say heat capacity is how much energy or heat is needed. Okay. Heat capacity is how much, I'm just going to say energy is needed to, because you keep using heat, can I say change the temperature of an object? If you aren't writing this down, Braden, please write this down if you haven't. Change the temp of an object by 1 degree. Is it Celsius or Fahrenheit? Celsius.
Celsius.
I like it. So it's the ability, the capacity. Has anybody ever touched metal?
Yes.
and you go, ow. Okay, so is metal got a high heat capacity or low heat capacity?
Hi.
High heat capacity. I would say actually low heat capacity.
Why?
Because,
It's hot.
right,
It's hot.
Because
it can get
right,
hotter
because it can get hotter and faster, which means it holds less heat before it changes in temperature.
That doesn't.
So it's got the ability to hold less heat.
That's like reverse
No, it doesn't.
Think about it like this. Has anybody ever seen, reverse psychology, has anybody ever seen Joey, what's the guy's name that eats all the hot dogs?
Joey Chestnut.
Joey Chestnut, okay. So imagine him in terms of heat capacity, right? He can eat, does anybody know what I'm talking about?
No.
Every year, there's like, on Coney Island, there's a hot dog eating contest. And Joey Chestnut is like the reigning champ, I think, for, I don't know. He must have like a hollow leg or something, and the hot dogs just go right into his leg. He can eat massive amounts of hot dogs, and he doesn't fill up. That would be Joey Chestnut having like a really high, if we're talking in terms of this, he's got a high heat capacity. He can ingest lots of hot dogs without vomiting, right? Me, I would have a low heat capacity, right? I would have a low ability to eat lots of hot dogs, and then it would affect me and I'd puke, right? So if we're talking about it in terms of that, it's all about how much energy an object can hold and not change in temperature. Let's just move on and we'll see if we can do that. Let's think about ocean versus land.
What?
Think about heating a pot of water on the stove. Shh, Sharon. Even though both materials get the same amount of heat, the pot heats up faster, right? You watch this thing, and if you touch the pot, it's going to be hot, but you can still put your finger in the water and be like, man, this isn't even heating up very much at all. This is because water has a high heat capacity. Materials with a high heat capacity need lots of thermal energy to get warmer. Underline that, okay? Need lot of thermal energy to get warmer. Put a star next to that. That's something with a high heat capacity. I'm going to circle this. Circle high heat capacity and then underline that. Heat capacity explains why the ocean heats slowly, but land can heat up very fast. Think of the hot sand and the cool water at the beach. How many of you have ever been at the beach during the day and you hustle to get across that sand because you're trying to get into the water? Why are you trying to get into the water so fast?
Because the sand's hot.
Because the sand's hot, but yet the sand and the sun are both under this, the sand and the water are both under the same sun. But one of them has a high heat capacity, meaning water. It can absorb lots of energy, lots of energy, lots of energy, and not change in temperature. Sand's got a low heat capacity. It's only got the capacity or the ability to absorb a small amount of energy, and the temperature starts changing. Okay? So which material, ocean, water, or land, has a higher heat capacity? Turn with your parachute partner and talk that out. Right, ocean. And I'm so sorry there was a typo there. It should have been ocean, water versus land. So then, ocean, right, has a higher heat capacity. In your own words, explain why this material has a higher heat capacity. I know this because what do we know from our lab, if you want, that tells us ocean's going to have a higher heat capacity? Turn with your parachute partner and talk that out. Ready, set, go.
Because the water would absorb more energy.
Is that it?
What do we think? How do we know that ocean has got a higher heat capacity than land? Jared.
Because it consumes heat slower than land does.
It what?
Consumes the heat slower than land does.
Okay, slower than land. Oh, I like what you're saying. It's not actually. They're both absorbing heat at the same rate. I know, it's crazy, right? But something changes. It's a little bit different. Sam, what were you going to say? Okay, so how about we go to our lab? I know this because in our lab, what did we see happen with water? Water absorbed more or less energy.
Less. How would it be more?
I guess it would absorb the same amount, right?
It's a funky.
Okay, water absorbed energy, but changed less in temperature? Do we
Yeah.
want to say same amount of energy? same amount of energy but changed less in temperature? It absorbed the same amount because they were both under the same light bulb. Does that make sense, Billy? They were both under that same light bulb, so the same amount of energy was going in both, but water changed less in temperature. It's got the ability to absorb more energy before changing in temperature. Let's look at how that affects air temperature. The air now we're talking about because air is above the ocean water, right? Air's all around us. Air above the ocean will stay at a constant temperature of what that water is. The water helps regulate the temperature of the air on top of it. Think about a layer of air just kind of resting on top of the water. It'll absorb or take up that energy to match it. Air above land will heat up and cool down more quickly because that's what the land is doing. This causes area by the ocean to have a moderate climate. Everybody look at your very last page of the lab, please, and look at the vocab I put there for you. What does moderate climate mean? Somebody read that for me. What does moderate climate mean? Read it out loud for me. Raise your hand and read it out loud.
It means,
Okay, Jared, read.
it means, wait, moderate, okay.
Moderate.
By classifying a place as moderate or
Temperate.
temperate, we mean that a place or region is not too hot or too cold between the summers and winters.
Right. So it's moderated, it's regulated, it's temperate climate. So has anybody ever heard of the story Goldilocks and the Three Bears?
Yeah.
Think about the porridge that was just right. That's our moderated climate. It doesn't get too hot, it doesn't get too cold, okay? So, landlocked areas like Iowa, I'm going to write that right next to it. Landlocked, and I'm going to say Iowa, can have a large range of temperatures. Do you remember our graph? I'm going to show our graph really, really quick so that we can remember what that looks like. All right, that's the blue. The blue gets really cold in the winters, really hot in the summers. There's a huge range between how cold it gets and how hot it gets. It's not moderated, it's not regulated. But what city is regulated? San Francisco, California, the green line. Where is San Francisco located?
Next to the ocean.
Right next to the ocean, so it's able to get regulated by those ocean waters. Okay, let me go back to where we were. See if I can line this up just perfectly, and there. All right, so landlocked areas like Iowa can have a large range of temperatures. Temperate, meaning moderate, areas near oceans are controlled by the ocean and the wind blowing over the ocean. If you have a hot bowl of soup and you're having somebody on the other side and you go, that air is going to pick up that energy from the soup and that's going to feel warm on that person's face, right? Because it's picking up the energy and carrying it over. All right, what type of climate describes areas near the ocean then? Turn with your picture partner and figure that out. It's in the reading. Hint, we underlined it or circled it. Moderate. It's moderated by the ocean. Moderate. Moderated by the ocean. In your own words, explain why areas near the ocean experience this type of climate. I know this because. What can we say from this reading? I'll give you 10 seconds on that. Ready, set, go.
Just because water has a higher heat busting.
And that affects the air. The air
You
temperature.
guys clearly won't talk to your fish
What do we think? What? What? Water is able to hold on to energy, okay, and not change in temperature. So in your own words, explain why areas near the ocean experience this type of climate. Because the water is able to hold on to the energy. How about we say something about, and it transfers to the air, right? How about this? I don't have it. So what did you say was the beginning? You're mumbling. Water, what?
Water is able to hold on to energy.
Okay, water is able to hold on to energy. What happens to the air then? Ah, right. Air moves over the water. Air moving over H2O absorbs energy. So what? Where's that go then? Where's the air go?
In the air.
Where's the air go?
Atmosphere.
That's what air is, man. So then how is it we're talking about how, in our own words, why areas near the ocean? So tell me about the land. How's the land staying the way it is? What happens to the air? There you go! Air moving over, H2O absorbs energy and transfers to land. Transfers to land. All that energy goes to the land and it keeps the land warm. Think about San Francisco, California. Has anybody ever been?
No.
Is it lovely? You were too little? Okay. So in the winter time, it doesn't get too hot. It's a nice cool current. Excuse me. In the winter time, it doesn't get too cold because the air, it's supposed to be cold on the land, but the air carrying over that water carries temperature from the water to the land. In the summertime, it doesn't get too hot. Why? Because the ocean current is a bit cooler than the land, and so it brings that temperature or lack of temperature over the land, keeping it nice and kind of steady. And again, we can see that if we look at our temperature graphs from the other day. We can see San Francisco stays pretty steady. It doesn't get too hot in the summer, and it doesn't get too cold in the winter. It stays within this band of about, 10, 15 degrees throughout the entire year. All right, nice and moderated, regulated by the ocean. Let's move on. All right, if anybody has any questions, you've got to raise your hand if you're like, Miss McGrain, this just doesn't make sense. Air temperature now. Did we do the air temperature? Yeah, we did this. Are we done?
Yeah.
Did we do everything?
Yeah.
Fabulous. Boom, done. Let's go ahead then and go back to our question of the day. You're going to need to get your phones out, please, for this.
Ooh, well,
If you don't have a phone, then get the information from somebody next to you who does, only because it'll just take too long to get our laptop set up. Today it says students will create a model that will help them understand how ocean currents help regulate regional climates. We've already kind of seen a little something on that.
Stop texting me.
Stop. Are they touching you?
What?
what?
There's not touching me.
We're going to do a quick search on Google. I want you to please look up the average July water temperature for San Diego, California, and the average July water temperature for South Carolina, Charleston. Could you please look that up for me? And then look up what's the latitude of both cities. If one of you wants to skip to the latitude of both cities, that would be great. You know, you don't all have to look up this one first because then we're waiting. So everybody pick something different if you want. And then I have put those over here for you. Sam, would you turn it this way, please? I've started something right here for us. Average July water temps, San Diego, California, Charleston, South Carolina. I'll give you a minute to do that while I get my coffee.
Wait, where do you write it?
In your notebook, honey, this is our daily questions. I so apologize. We are kind of going back in time a little bit. This is going to help jumpstart us for what we are doing. A connection to heat capacity, but then also going towards the investigation we're doing today on ocean currents. Did anybody yet find the average July temperature for San Diego, California? Water temperature. 60 what? 68. Do you have corroboration that that is 68, Kendall?
Yeah.
68, okay, so I'm gonna say 68, can I assume that that's Fahrenheit?
Yeah.
Does anybody have Charleston, South Carolina? 83, and anybody else?
I got 83.
Okay, 83. Okay,
Did you run, Jen?
now, can somebody please tell me what's the latitude? Now remember, latitude is distance from the equator. Let's write that down so that we remember. Latitude is the distance, and I'm gonna say north or south from the equator. And then I'm also gonna draw a picture because that's how I learn best. I'm gonna say this is 0 degrees, that's my equator, and I'm just gonna go up or down, okay, on my earth. I'm gonna say this is north and this is south. That way, when I'm looking at this for my exam, I'll be able to figure that out. So does anybody have what the latitude of San Diego is? 32 degrees north. 32 degrees north. And let's just go ahead and stick with the whole number. Don't worry about all the other little 0.715, blah, blah, blah. Anybody have the latitude of Charleston yet? What do you got, Cole?
32.
Okay, so we got 32 degrees north. All right, let's look at this for a minute. Both San Diego, California, and Charleston, South Carolina are coastal cities. What does that mean?
I don't know. Oh, that means on water.
They're on the ocean.
Yep.
And are they at the same latitude or different latitudes?
Different.
They're both the same latitude. They're both 32 degrees north away from the equator. So they're both exactly the same distance from the equator. So we've just said that coastal communities, cities that are on the water, are regulated, right? They should be nice and even. And we know, Brayden, that both of these cities are the same distance from the equator, so they should be getting the same amount of sunlight energy. Why then is this a colder current and this a warmer current? What the heck is going on? With your pair-share partners, why if I jump into the water in San Diego, California, is it going to be colder? And if I jump into the ocean at South Carolina, it's going to be warmer. Turn and talk that out. Ready, set, go.
On different sides of.
What the heck is going on there? Yeah, what
One's on
happened
the
to
East Coast, one's on the West Coast.
So there's different water.
The East Coast has the Gulf Stream, which goes through the Gulf.
Ooh, track burn.
Actually, not.
Were you
which
jumping,
goes through the Gulf
coast?
Sea, Gulf of Mexico.
Are you walking?
That brings warm water to the East Coast, and it also brings it to Europe.
Okay.
So the Gulf Stream.
All right. We're going to go ahead and look at why that is. Catherine, go quick, okay, because we're about to transition. We're not going to talk about why that is now. We're just going to go ahead and have you think about it. And now what we're going to do is jump into, we're going to see.
Yeah,
the bathroom.
Yeah.
That's what I was gonna ask.
Cole, go.
Oh.
Thank you very much. I appreciate that. My bad. I appreciate y'all keeping me honest about that. Everybody get out your ocean circulation lab, please. Get out your ocean circulation lab. It looks like, well, it's got this.
It's a new one.
Jeremy really did not care.
Was I talking to you? I was having a conversation with Sam.
Whoa, back it, like beep, beep, back that up.
What?
Back it up.
Back it up. Beep, beep, beep.
I asked Samuel how his day was, so then he asked how mine, and then she just stopped.
Okay, well, she has a hard time focusing.
How's your day going?
She says
Yo,
this every
why?
day.
Yeah, why are we targeting me over here?
Let's go ahead and read the introduction, shall we?
No.
Most of you probably have not given much thought to the oceans as regulators. What's a regulator?
I don't know.
Okay.
Water.
Let's imagine that there's a
Water.
group full of people and somebody walks in the room and then all of a sudden everybody gets taken down and they're like, oh gosh, I feel sad now because so-and-so is here. Or let's imagine that there's a group of people and they walk into the room and it's like, yeah, Kaylin's here. God, it's gonna be a great day because Kaylin showed up.
Aw.
Kaylin would be a regulator. Did you say that's not how it is? Kaylin would be a regulator, right? You kind of control the atmosphere of the room.
No, you're right.
So So oceans are thought to be regulators of global climate. We're gonna dial in and see why.
Kendall.
Those of you who have visited both the east and the west coast of the United States may wonder why the temperature of oceans and beaches at similar latitudes vary as greatly as they do. And if you haven't been there, I wanted to go ahead and show you what those temperatures were all about looking at the oceans. This investigation is designed to help you understand how surface currents are the currents that travel along the top of the oceans driven by wind, transfer heat from one region to another, and moderate or regulate the Earth's climate. This is a real honest-to-God story.
For
On
real?
May 27, 1990, 40,000 pairs of Nike sneakers were washed aboard over a ship bound from Korea to Tacoma, Washington. So there were large shipping containers, there was a storm, and these shipping containers were washed in the ocean. In the months following this North Pacific Ocean spill, beachcombers, what's a beachcomber? Yuma.
Somebody that like looks for trash.
Yeah, or treasure. My sister walks along the beaches and she looks for sea glass, glass
You
that's
look
been
for
tumbled.
trash?
Treasure.
Sea
Oh.
glass. But beachcombers found shoes at the locations reported in the table below. So what we're going to do first is we're going to plot the data from the table on the map of the North Pacific Ocean. The location of the initial spill is marked with a large X. And I'm so sorry, I did not put the large X on here. So let's go ahead and do that together.
Yo, what's that thing? What is it, Hawaii?
All right. The location of the spill, day 1, was at 48 degrees north and a longitude of 161 west. So what we're going to do is we're going to put a mark there. I'm going to change my color of my pen to red so that we can see that a little better. And then we'll go ahead and walk through this a little bit together. I'll get you started. So I got to find 48 north. Okay. So if this is 40 and this is 60, what's the line in between represent? This is 50 degrees north, which means 48 is going to be somewhere around here, right? Now, what was my longitude, please?
161.
161. Okay, so I'm going to look at the bottom.
161.
151.
161 west.
161 west. Okay, so I've got 160, and this is 180, so I know 161 is going to be somewhere around here. So I'm going to put a big X right here. That's the location of the spill. Everybody put an X in that area. And again, I'm just a little bit on this side of 160 because I got to go to 161, and I got to be at 48, which is somewhere, I'm guessing, around here. All right. Now, the first shoe was found where? Give me something. 48, so I'm still at 48, and?
125.
125. So if this is 120, 140, this would be 130, which means 125 is somewhere in between. And so I'm guessing it's going to be somewhere like right here. I'm going to put a red dot.
What?
Yeah.
Is that not right?
No, that's right.
It's on the beach, right? On the
I went
coast?
to the wrong one.
Okay. What's the next one?
Location of the next shoe discovery is 46, 125.
46, so it's going to be halfway through here at 125 still, so I'm going to put it right down below that. Okay, what else? Where's another one?
45
One.
and 124.
45 and 124, so again, it's probably going to be right below that.
These
So they're
people are
finding
lucky.
shoes all along the coastline. What's next?
43, 125.
43, 125, so again, it's probably right below that. And then what's next?
157.
21, okay, so this is 20, so I know it's gotta be right above that, and you said 157?
Yeah.
Okay, so this is 150 right here, so 157, I'm guessing they found it
Hawaii.
right here in Hawaii.
Hawaii.
Hawaii. And then what's the last one?
36, 140.
Okay, but now what's the direction? Is it east or west? East now, right? So it's 140 east, which is right here. That means I gotta go up to, what's the thing? 36. Okay, so this is 40, that means this is 30 right here. So 35 would be in between, so it's like right here off the coast of Japan. Are we good?
Yeah.
All right, let's see what we do next. It says plot the locations that the shoes were found and draw arrows on your map from one location to the next to indicate the direction of the North Pacific Current. Okie dokie. So it went here, and then it was in this area. Let's make a arrow. Then it looks like the current comes down in this direction because it was depositing shoes along the shore. Then it looks like the current goes this way to Hawaii, and then the current goes from Hawaii up towards Japan here. Are we good?
Yeah.
Okay. Based with this information, and Seth, when Hudson comes back, will you help him get back to her? Okay, thanks. You were looking at me like you didn't understand what I was saying. So now, let's go ahead and look at what we do next. Locate the equator on the map. Water near these low latitudes is warmer than water in the higher latitudes. Okay, so let's find the equator. The equator is 0, so this is the equator. So I'm going to write equator. Okay, this is the equator, 0 degrees latitude. That's the equator. Hey Hudson, we just went ahead and plotted all of our dots, and then we wrote in arrows to show where the current is flowing. And now we're just locating the equator. All right, the question says, why is water at the equator warmer than, let's say, water up here at 60 degrees north? Turn with your pair share partners and talk that out. Why? What's going on at the equator that makes it special?
Oh, yeah.
So it's like if you have a ball and you
Zai, I'm going to you.
keep
I'm going to ask
the
you.
part closest to the
Will be the warmest.
Why not? You're full like piss and vinegar and attitude.
Hi, Zai. Zaya.
Why is it that the equator's water is going to be warmer than like up by 50 degrees
Because the
north or
equator's
60
hot.
degrees north? What's going on? Alex?
There's more direct sunlight.
More direct sunlight, write that down please. That area gets more direct sunlight from the sun, right? That area receives, oops, I spelled that wrong, more direct, I'm gonna say energy from sun. All right. Then it says find the letter A on the map. This represents the country of Japan. Has anybody been there? Have you? My daughter spent the summer there at a naval base. She was doing swim lessons for the Navy people. She lived there for 3 months. Loved it. And I'm like, ah, good for her. So if you have those opportunities in college, by God, you take them. Japan has a temperate climate. Changes between summer and winter in this country are generally relative moderate, rather than extreme hot and cold like in Iowa. Why do you think this is? With your pair share partners, share that out. Why is it that Japan, right here, right, has a moderate climate, about 70, oops, that's not going, about 70 degrees Fahrenheit? Why do you think?
island that is constantly having more water.
Aileen, why do you think? Yes, why do you think? Where is it? It's
And there's
located where?
water on
What?
both sides.
Why is California, or excuse me, Japan, why does it have a moderate temperature throughout the year? Yeah, because it's right on the ocean. Yeah, the ocean is able to moderate those temperatures. The ocean moderates the temperatures or regulates the temperatures. Are you with me? Zai, write this stuff down, man.
You haven't wrote anything down yet.
I have written down lots of stuff. I'm not gonna write anything down. Oh, good. So then write this next one down. We just gave the answers for that. I'm not gonna write anything else down on the board for you. I want you to be able to do it on your own. I don't wanna do too much for you. Get your foot off the desk. Who do you think you are? Oh my God. Okay, now, we said why we think this is. Find letter B on the map. You know what? I'm going to stop talking, and I want you to be able to, with your pair share partner, you finish the rest. Books are in the cupboard. After you're done, your time is your own. But I want you to think about this,
Yeah.
B and A. Be very careful and deliberate in your thought process. Sam, do me a favor and shut that off.
This represents